In today's lesson, we're going to talk about chemical reactions, so lesson number 12. Now, the big idea is that there are many types of reaction that can be identified by the species involved in our reactants. So what are these terms? Reactants and products and chemical reactions. Well, so we went over these topics before in a previous lesson. What is a reactant? What is a product? But what a reactant is the starting chemical. What the products is the resulting chemical. So what are chemical reactions? Well, first of all, there are 6 major types of reaction that we're going to study in this course. And a chemical reaction is one where, so a chemical reaction is where the starting chemical is different from the resulting chemical. So a chemical reaction is where reactants are different from products. Which means that if I look at this, reactants will turn into products. And this is what you do when you balanced. Now the arrow just tells you the direction of the reaction, but doesn't actually tell you time. So reactions can happen in a split second, in a couple nanoseconds, to years and years. The arrow again just tells you the direction in which the reaction takes place. So we're going to go into our first type of reaction, in which we call a synthesis reaction. Now some of you might have heard the word synthesis before because it comes from the word to synthesize, which means to make. What a synthesis reaction is when you have 2 or more reactants combine to form one product. And usually it's 2 or more elements to form a compound. So what does that look like? Well, an example that would be, for example, A plus B will come together to form AB. So if I were to write a real world example, such as for example when hydrogen gas comes in contact with oxygen gas, it can actually form water. Now if I were to balance this, we need 2 hydrogens to form 2 water. So this is an example of a synthesis reaction. Now what if one of the chemical was a metal and the other chemical was a non-metal? Such as for example, if I write down, if you had aluminum plus chlorine, well this will form aluminum chloride. Now what is the chemical structure or formula of aluminum chloride? Well, we know aluminum has a +3 charge. And we know each chlorine has a -1 charge. It's going to be where you're going to have to now write it like you're doing for chemical formulas and balance all those charges. So you're going to need to write 3 chlorines in order to balance out your aluminum chloride. So again, this is where you need to balance out your chemical reaction, and you have 2 of these, which means you have 2 of these, and you have 3 of these. So you have 2 aluminums plus 3 chlorine gas will give you 2 aluminum chlorides. So you gotta make sure, if you want to star this, you gotta make sure you balance the charges of ionic compounds. So this is an example of a synthesis reaction. So the next type of reaction we're going to go into is called a decomposition reaction. A decomposition is just the opposite of synthesis. If synthesis means to put together, to make, decomposition means to break apart. So it's the opposite of a synthesis reaction. So what this means is a single product breaks apart into two or more reactants. That is the opposite of a synthesis. Now, to be more clear, a compound breaks apart into elements, if you want to be very certain. So if I were to write this out as an example, you now have some compound, such as, for example, CD, is going to break apart into C plus D. Now, if I were to write this out as an example, I could write, for example, when iron 3 chloride, when it breaks apart, it's going to break apart into iron plus chlorine gas. Now, Cl cannot exist by itself. Cl is what we call a diatomic molecule. It means it can only exist in pairs in nature, which is why it's Cl2. Now, again, you want to make sure you balance out this reaction. But the reason, again, why this is Cl2 is because there's something called the diatomics. The diatomic molecules are elements that can exist in only as pairs. So where do you find diatomic molecules? Well, if you look at your periodic table, you will see that the diatomic molecules are the molecules that exist in this section. They are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. So I usually call it, you could call it two different names. I'll write them both out. You call it hydrogen plus the 7 because it forms the number 7 in the periodic table. So that's one way you call it. It's hydrogen plus the 7. Or the other way is an acronym called Hofbrinkel, which stands for hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, and chlorine. These are the diatomic elements. So that is our next class of reaction. So if I now go into the next class, this next class is called a single replacement reaction. A single replacement reaction is where one element reacts with a compound. So if the element, so here's a little if statement, okay? If element is metal, it will replace the metal in the compound. And if element is nonmetal, it will replace the nonmetal in the compound. So these are both in compound. So what that means is this. You have two different versions of this occurring. You could have, for example, if A is your element and it's reacting with a compound BC, if A is a metal, it will swap with B, which is also a metal because of how it's written, and thus you're going to get B replaced and you're going to have AC. If you write this as, again, A gives you BC, if this time A is a nonmetal, it will now swap with C in the compound because C is a nonmetal. And thus this time you're going to get C kicked out and you're going to get B combined with A. So this usually happens when A is a very reactive element and it reacts to become more stable by reacting. So the product will be dependent on what is getting kicked out. Remember, ionic charges still apply. So if I give you this reaction, such as, for example, if I write copper reacting with for example, if this is copper 2, reacting with iron 2 chloride, what will happen is copper is a metal. So thus it's going to kick and swap out the metal of iron. And you're going to get iron kicked out. And copper 2 chloride, because it's positive 2 and chlorine is minus 1, you're going to get, because of that, 2 chlorine still. So you're going to get copper 2 chloride. And this is already a balanced reaction. Now, if this element was a nonmetal, then you're going to get this swapping with chlorine. For example, if I change this reaction to, instead of copper, it's going to be, this time, it's going to be, for example, oxygen. Now, oxygen is a nonmetal. The reason why I'm writing O2 is because it's diatomic. Oxygen will kick out the chlorine. Thus, you're going to get chlorine outside by itself, and you're going to get iron, in this case 2 oxide, joined together. Now, the reason why it's FeO is because iron, in this case, is positive 2. Oxygen is minus 2, thus you only need one of each. That's why it's FeO. So this is an example of what we call a single replacement reaction, in which, again, the charges still apply to your ionic compound. Let's move on to the next class of reaction, which we call a double replacement. A double replacement reaction is one that involves two ionic compounds. It's a reaction between two ionic compounds, which means between two metal-nonmetal compounds. It's what happens here is the metal slash nonmetal will basically switch partners. We'll swap partners. So what does this mean? Well, if I write this as a reaction, if I write this as an example, if AB reacts with CD, what happens here is that these two will swap its partners. So A, which initially was with B, A is now going to be with D. So in this case, your compound is going to be AD. C, which was initially with D, is now going to be swapping to become with B. And this is called a double replacement reaction. So what's going to happen is if I write an action example, if you have, for example, NaCl plus, for example, lithium oxide, you're going to get a switching where sodium, which is initially with chlorine, is now going to be with oxygen. So sodium, which charges still apply, it's positive 1, oxygen is minus 2, you're going to need 2 sodiums to balance out this oxygen. So it becomes Na2O. Lithium was with oxygen, is now going to be with chlorine. Lithium is positive 1, chlorine is minus 1, thus they're already balanced in charges, so it becomes lithium chloride. So this is a double replacement reaction. Usually this reaction occurs, if you learn this in chemistry 12, is to always try to form some insoluble compound. Now if you were to balance out this reaction, you would see that you will need, in this case, if you look at the sodium, you're going to need 2 sodiums here, and thus what's attached to sodium here? Chlorine. You have 2 chlorines here, which means you have 2 chlorines here. And likewise, if you look at your lithium, you have 2 lithiums, and 1 oxygen, 1 oxygen. So this reaction is now balanced. So that's what we call a double replacement reaction. Now, a special type of double replacement reaction is called an acid-base neutralization reaction. An acid-base neutralization reaction is where you're going to perform a double replacement reaction, but this time it's going to react an acid and a base. So it's a type of double replacement reaction. Now I'm going to write double replacement as DR. Double replacement DR. So in this case, it's an acid plus a base will swap partners to give you always these two things, a salt and water. So what's going on? Well, acids, as we learn, are compounds that start with hydrogen acting as a metal. And bases are compounds that have hydroxide acting as a nonmetal. So what you have is, if I write this out, you can have some hydrogen attached to some nonmetal. We'll call it A. Reacting with some base attached to the hydroxide, which is OH. So what's going to happen is your hydrogen is going to swap with the B, the metal of your base. And when this happens, you're going to form some salt created by the metal of the base and the nonmetal of the acid. So you're going to form Ba. What's left over? Well, you're going to have hydrogen join with OH. And this is where you get your water, which is HOH, which you know as H2O. So if I were to write this as a type of reaction, you're going to see, for example, if I write, for example, HCl plus NaOH, so hydrochloric acid plus sodium hydroxide, is going to form your salt, which is always from the metal of the base and the non-metal of the acid. So in this case, you're going to form Na, which has a charge of +1, chlorine, which has a charge of -1. Because you only have one of each, it becomes NaCl. And the other thing is going to be hydrogen joining with OH, and thus you're going to form HOH, which is your water. So this is why double replacement, acid-base neutralization, is a type of double replacement. Now our last type of reaction is going to be what we call a combustion reaction. Now a combustion reaction is actually one of the easiest types of reaction to predict. Now what is a combustion reaction? A combustion reaction always involves some hydrocarbon, some organic hydrocarbon reacts with oxygen gas, which we know as O2. And it will always form these two things, carbon dioxide and water. Always, always, always. Now you might know of a combustion reaction as an explosion or a fire as well. So if I were to write this reaction down, you could have hydrocarbon with any carbon, amount of carbon, which we'll call CX, some amount of hydrogen, which we'll call Y, will react with oxygen gas, and you will always form CO2 plus H2O. So how do you identify this? If you see some hydrocarbon reacting with just oxygen gas, you always form these two products. So an example of this, for example, could be CH4, methane gas. Will react with oxygen, will always form CO2 and H2O. You could have, for example, propane, what you burn in a barbecue, C3H8. React again with oxygen gas, will always form CO2 plus H2O. So as you see here, you're always going to form these two products. Now, a demo I would be doing is called the milk carton rockets, where I fill a milk carton with some methanol and then light the end of the milk carton with a flaming splint. So I have a video of this done previously, and you could see in this video, if I bring this over here and light this back, you could see in this video that when I light the rocket, so here's your milk carton, here's your wooden splint on a meter stick, everyone's safely away and they are actually wearing goggles, this is what happens. And now if this video actually loads, that will be useful. I will try a different program. So there we go, it actually works here. Okay, so if I go back, you would see that this shoots across the room. So if I were to freeze this at different points, you can see as the flaming splint gets into the and lights the end of the milk carton, the milk carton will start to combust because there's methanol inside of it. And you can see that the milk carton will fire across the end to the other end of the classroom. So this is a combustion reaction. So if you want to watch it again one more time, that is what we call a combustion reaction. So let's practice these types of reactions. So here I have a few examples that we're going to work on. There's about 5 examples. So what you're going to have to do is you're always going to have to predict what your products will be. Your complete reaction, you're going to balance that reaction. So the first reaction, aluminum is an element. Oxygen is an element. You have 2 elements reacting together. This must be a synthesis reaction. So what must a synthesis reaction form? It will always form a compound because aluminum is a metal, oxygen is a non-metal. You're going to form an ionic compound, which means you have balance of the charges. Aluminum has a charge of +3. Oxygen has a charge of -2. If you complete your LCD reaction, you're going to find that you're going to have this reaction forms aluminum. So Al2O3. So now we predicted it, so it's got to be a synthesis reaction. Now you completed the reaction. Your last step is to balance this reaction. So you see you have 2 aluminums and 2 aluminums. But you have an odd even number of oxygen in this case. So you got to perform your double odd even rule, which means every number you just balance doubles. So the 2 becomes a 4. This 1, which would have been here, is now a 2. And thus now you have 6 oxygens, so you can multiply this oxygen by 3 to fully balance it. So this is a synthesis reaction. Your next type of reaction is going to be NO2 by itself. It's a compound by itself. So thus it is a decomposition reaction. A decomposition means that this compound is going to break apart into its elements. So it's going to break apart into nitrogen and oxygen. Well, nitrogen and oxygen both are what we call diatomic molecules. Because they're diatomic, they exist in pairs in nature. They can only exist in pairs. So that's how we write this out. So now your last step is now to balance it. Well, you have 2 nitrogens here. You have 2 nitrogens here, so you got to put a 2 in front of this. You have 4 oxygens now. You need 4 oxygens, so you got to put another 2 in front of this. So this is what we call a decomposition reaction, where the single compound breaks apart into its elements. The last 3 types of examples are going to be other cases. So if you look at your first example, you're going to see chlorine gas reacting with calcium bromide. Well, an element reacting with a compound tells you it is what we call a single replacement reaction. Chlorine is a nonmetal, so it's going to kick out the nonmetal. The compound in this case is going to kick out the bromine. So bromine, being a diatomic, is going to get released out in the reaction, and you're going to form your new compound, which is going to be calcium and chlorine joined together. Now calcium has a +2 charge, chlorine has a -1 charge. You're going to need 2 chlorines to balance out this reaction. So in this case, this is your predicted reaction. So this is called a single replacement, which I will write in SR. And it's already balanced as well. Now, any point of this video, if you want to try something out, please remember to pause the video, and thus you can try it on your own. So let's try the next example to see if we can get this. So our next example is HNO3 plus SROH2. You have hydrogen acting as a metal. You have hydroxide. This is not a double replacement. It is a type of double replacement. We could call this an acid-base neutralization. Some people just call it neutralization. I'll write out the whole word. So what's going to happen is you're always going to form water and a salt. The salt is going to be coming from the metal of your base and the non-metal of your acid. So in this case, strontium has a +2 charge. Nitrate NO3 has a -1 charge. So you're going to need 2 nitrates to make this a balanced compound. So you're going to need to put a bracket NO3 2. Your other compound is going to be water, HOH. And now you're going to have to balance this. So you have, as you see, in this case, 1 strontium on the little reactant side, 1 strontium on the product side. You have 2 hydroxide, you only have 1 hydroxide on your product side. So you're going to need to put 2 hydrogens. Your last step, balance your hydrogens. You have 1 hydrogen here, you have 1 hydrogen here, so you need to put another 2 in front of this. And what's attached to the hydrogen? The nitrate. You have 2 nitrates on your reactant side, you have 2 nitrates on your product side, and now you are balanced. Your last type of reaction is going to be a combustion. Now what you can do is you can actually cross out this S here because you can't do combustion that involves sulfur yet. So what do you have to do? Well, in this case, you're going to have C4H8 react with O2, and that is what we call a combustion reaction. Combustion reactions are simple. They always form CO2 and H2O. Now the reason why you want to write H2O instead of HOH here is because HOH is only when you deal with it where water is acting like an ionic compound. Because this is not really an ionic type of reaction, there's no replacement going on, you can keep water as H2O. So now you want to balance. You have 4 carbons here, you have 1 carbon here, you put a 4 in front of this to balance the other carbons. You have 8 hydrogens here, you have 2 hydrogens here, you can put another 4 here. Last but not least, you balance out your oxygens. You have 8 oxygens here, you have 4 oxygens here, you have 12 total on the product side. You need 12 more, or 12 total on reactant side, so you need to put a 6 in front of this. And now they are balanced. So this is the end of our types of reaction lesson. If you have any questions, make sure you send me an email. But as always, stay safe and healthy, and I'll see you soon.